Good morning, everybody. We are the Field Productivity Forecaster team.
My name's Anita.
I'm Christian,
I'm Clarissa. And I'm Laura.
and our mentor was Dr. Glenn Bruns of CSUMB, as well as Nathan Dorn of Food Origins. Food Origins is a company working towards taking data science to agriculture, and the motivation for our project was to reduce crop loss. It is said that by 2050, we will have 9.7 billion people on this world, and we will need more food to keep everybody alive. So crop loss is a big problem in the agricultural industry. Staffing issues are another big issue. Making sure that you have enough people to get all the crops out of the ground when it's ready, and making sure that there's not enough, that there is enough people to pull the plants, but not to have too many people out there at once. And the global impact will always keep those people fed. So our project objective was to create a real-time short-term forecasting module to allow farmers to make more accurate labor staffing decisions using data modeling to maximize the earning potential of the farmers as well as the people picking the crops as well.
So our project solution workflow was pretty simple. We needed a few things from Food Origins. We needed the job data, which was collected by a proprietary scanner that they have, and the data that we collect is given to us in a table form. You can kind of see it to the right here. We collect things about the picker and then about their interactions with the crates. We know how fast it took to pick those crates, and we know exactly where that crate was picked. And through the data, well, first we needed to, like any data scientist does, we needed to clean it to make it workable. We needed to account for anomalies such as mass crate scans. So if someone just picks everything and scans at the same time, that's not useful for us. So we dished that data. We also wanted to make sure that we didn't let the standardized breaks influence the prediction that we made. And we also wanted to account for pickers that left. And then after we had a working data set, we were able to train our model to calculate the time remaining. And then this is a potential way that Food Origins can integrate our module into their application. You can see a screenshot of their web app now. So what a farmer does is click on the field of their choice, which represents the job. So a job is when they start a harvest, when they finish it on a certain location. All the red dots are all the data points that we have about the crates. That gets fed into our module. Some magic happens, and then we output a predicted job end time. So you can see that this will be done at noon today, plus or minus 2 hours.
So with our prediction, we wanted to know how accurate it was. And so we have these three graphs showing just that. And so on the left, you can see this is like the estimate of a finish time. And so as time goes on, you can see that we overestimated at first, and then it gets closer to the actual time, which is like the red line. And so in the center, you can see that shows the percentage of error for our prediction. And so we simulated a job to be able to produce these graphs. And so in the middle, we simulated like over 100 times to see how accurate our prediction was. And on the far right, you can just see the same percentage of error, but it's represented as a box plot, which shows the median and like the 25th percentile and the 75th percentile for just our average error. For this, we did a because we can't show our actual algorithm like working. We have this graph showing each dot is a crate being picked, and so ignoring like the time and the number of crates because it's changing. We want to just pay attention to the label, and so at each label we're predicting estimated completion time and then our accuracy, which give us the plus or minus how many minutes it's going to take to complete it.
So for the next step, we would like to improve our algorithm's robustness by considering the field health. For example, does this field tend to yield less crops or more during certain times of the year. Also, we want to be able to make predictions based off of the crew that is coming in that day to work and pick the berries. So, for example, if this crew worker is picking faster than other people, we will take that into account in our prediction. That would mean maybe less time needed to pick all the berries. And the final step is for Food Origins to integrate our module into their webpage, so the user could start getting those predictions. So we would like to acknowledge our mentor, Dr. Glenn Bruns, the CEO of Food Origins, Nathan Dorn, and the data analyst, Richard Sowers. So thank you. If you guys have any questions, come visit us at our poster, and we have fresh strawberries that we're